What I'd like to do now is spend some time going over the different classes that we just saw in the previous slide. And we're going to start with the base class, which, as you recall, is class building. And the way that this class is set up is pretty typical of what you would set up anytime that you're going to do an inheritance structure to your program. Usually, I will have a set of symbolic constants that I use to make the decision process look a little bit easier in the code. Actually, I've stripped out, we have very few methods in any of these classes that we're using, but the more methods that you have, the more useful these different symbolic constants become. And you'll find it a lot easier to look at the code and see the word apartment rather than a number 1. And it's just a simple way of making the code easier to read, really, more than anything else. And I also have taken some time to label each one of the types of strings or classes that come in. Then I have protected string address, and you'll notice that all of the properties that we have in this particular class are protected. And what that means then is that all of the subclasses will have full access to all of those specific properties in the base class. Then I have a constructor. The default constructor is overridden with this simple one that says address not closed yet. And she asked me to put this in because sometimes she would have properties that were in the process of being purchased, but she wanted them to appear in the list, but she wanted a way to distinguish the fact that they were sort of in transit, if you will. The second constructor should look familiar to you now, and you'll notice that we've used the word this at the end, and if you'll recall our discussion from earlier, that means that the no parameter constructor up here gets called before anything else. And this sets the address to a default value of not closed. So if it would come up and there's nothing else assigned, then we can see that this particular property has nothing being assigned into it. The rest of the information is passed in as a parameter list to the second constructor. And you'll notice here we're saying that if address equals null, in other words, they're passing in the fact that we don't have the address of the property, but they have pricing. What that means is that we actually have a not closed apartment or commercial property of some kind in the process of being purchased. In all other cases, the properties are filled in according to the values that have been passed in. That should look fairly familiar to you now. With respect to the property methods, each one of these property methods should properly have its own property method assigned to it. And the reason is because if you don't do that, well, number one, there's no way to access the particular property of the class. And especially from the outside world, they would all be invisible. But the reason, and you could get by that by making everything public. If you made this list up here, if you changed all of these protecteds to public, those properties then become visible everywhere, including the subclasses. But as we know, making those public defeats the whole concept of encapsulation. So by using protected, we're still isolating and protecting our data without exposing it to the outside world. And when we do, the outside world must go through our property methods. And by doing that, it allows us to perform basic checks to make sure we don't get garbage data into the class itself. So each one of these property methods then gives us a method of, or a means by which we can check to make sure that we're getting valid data into those properties. Gets and sets, we've used those before. Because we've made these public, all of these then become part of the public user interface. And what we're saying there by public user interface is the programmer who's writing the code back in, say, form main, like we have over here. I'm sticking with that convention I told you about before of setting the program start to a form main. By making these all public, then all of these properties become fully visible through the property method in something like form main. We also mentioned that value is going to tell us what has been passed in anytime that we're doing a set, and it will take on the same attributes, data attributes, as the method for the property method itself. Decimal in C#, using a suffix M means that we're using a monetary value, and rather than use double, decimal is used for dollar values. And the reason is because you have 28 digits of precision with the decimal data type, so you don't start losing pennies with large numbers. That's the good news. The bad news is each one of those takes up, I believe it's 16 bytes. Decimal for monthly payments, again, just doing some basic checks. These checks will be as complicated as you need them to be to ensure that there aren't bogus values being put into the various properties. Date and time, value will come in as a date and time, so you have full access to all the properties and methods associated with a date-time object. And then the building type, here again, we're using the symbolic constants here to check the range of whatever value happened to come in. Once we've done that, we have made a public interface for all of the various property methods. They're up and running. They have at least rudimentary checking to make sure that we're not going to put in bogus values. Then we get into the general methods. And here I've only put in two general methods. One is the property summary, which just details what the property looks like. And the second one is something called snow removal. And I'm going to run the program right now so that you can see sort of what this means. The first thing is the show properties. And what that does is it goes through the list of the different property types, and using that method, property summary, displays the details on each one of the properties. And we'll show where this information comes from in a minute. What I also want to show you is the use of the snow removal function or method. And you'll notice that each one of the each one of the commercial properties has a different person that's getting called or who is responsible for removing snow. One of them's John, another Acme, and then this one, no snow removal available. What that means is, well, actually for this lady's properties, the tenant is responsible for the snow removal, so no message has to be sent. So that's what the program looks like when it's run based on these two general property methods. All right, that's all there is to the building class. Now let's take a look at the apartment class. The apartment class, again, because class apartment is a building class, the first thing that we want to do to establish the hook into the concept of inheritance is the first line that defines how the class begins in its definition. And remember, the colon is really an abbreviation for inherits from. And you've seen this before. For example, every program that we've written that uses the Windows interface, we had the Windows Forms elements from the library. And so what we were saying is that form main inherits all of the properties and behaviors of a Windows form. Well, we're doing exactly the same thing here with the apartment class, except in this case what we're saying is class apartments inherits all of the base properties and methods associated with class building. And in that diagram, when we said that the various subclasses, apartment, residential, and commercial, were ISA relationships, this is what establishes that hook that ties class apartment to class building. Once you do that, once you have a class definition that begins with this syntax, what you're doing is you're saying this subclass has full access to any and all methods and properties that are of the protected status mode or public. Now, the general methods back in class building you'll notice all of those are public. And the reason that we do that, you should be able to figure this out for yourself, is because those general methods form the public interface to the base class. Apartments then, because of this inherited relationship, also inherits the ability to exercise those particular methods. They would have anyway, though, because they're classed as public. What follows next are the instance variables, or the properties. Sometimes you'll see instance variables. I just put this in because in some languages you'll see instance variables used and instead of properties. These are really properties, but I just put the instance variables in here because in some other languages like Java, you'll see instance variables quite often in subclasses rather than properties. It's to try and give the idea that these are in addition to the properties that are being used in the base class. Now here, we use the word private for all of the properties. And as you know, the reason that we use private is so that they're not visible to the outside world. We could put the word protected there, but it makes no sense because there's not another class below this. If we wanted to, we could have a subclass to class apartment. So we could have, let's see, what kind of apartments might we have? Townhouse apartments versus ranch-style apartments, or one single floor versus two floor. So we could have class multi-floor and class single floor as subclasses below apartment. If that were the case, then we would want to change these from private to protected, because by making them private, no other class can see it, including the base class and including any subclasses that might be derived off of class apartment. So the actual storage class here, since we're ending the chain, the inheritance chain with this class, we can label them private, and we should label them private. In all cases, traveling down the chain of inheritance, the last class in the chain should always have all of its properties or instance variables with the private storage or access specifier. Okay, so we have just 3 different types of properties in the apartment unit type that distinguish it from everything else. Because we've made all of these private, it makes sense to have public property methods for each one of those. If you didn't do that, as you know, you would have no way of changing any one of those particular properties because you've labeled them with the private access specifier. So again, we have some basic checks to make sure we don't throw garbage values into any one of those 3 properties for this particular type of unit. Then, in the bottom, we have something new called override. What we're doing here is we're saying that this method overrides or can override the snow removal method that's in the base class. So if I look here, I'm saying I have remove snow and remove snow in the building class, but by putting it with the override specifier, what I'm saying is anytime a message comes in or an event comes in that says remove snow, always go to this one first. If you find a remove snow method in this class, you should use it. If you don't find it, okay, back the boat up, go back up to the building class, and use the one that you find there. So that way we can have any event that's passed to the base class can pass it down to a subclass and make the decision there whether we want to use it in the subclass or whether we're forced to use it in the base class. So override is just simply a way of saying, okay, this message comes in, I've got 2 places where I can send this. I've got 2 remove snow methods. I've got one in the base class and I've got one in the subclass. Which one should I use? Well, because we have the override modifier in the subclass, this says that's the tiebreaker. So the message should slide down to the subclass and be processed there. Now, let's go look at the commercial side. Again, class commercial, to work in this model, the way we've set it up, must inherit all of the behavior that comes from class building. So this establishes that inherits from relationship, and it gives this class also the is-a relationship from the child to the parent class or from the subclass to the base class. Again, private for exactly the same reasons. We want to isolate these particular properties from the outside world. Again, we have a constructor that allows us to pass in the creation of a commercial building class by passing in the data in this particular parameterized list. If we don't do that, it doesn't appear that there's any way to do it without passing in the data. Well, actually there is, because we know every class gets a parameterless constructor free. Windows provides that code actually in the background, and there's nothing that you can do to edit that code. All right, once we've done that, then we go to the property methods, and again, the purpose is exactly the same. We have to make those public to be able to talk to the private member. If we don't have this as public, there would be no way to change the value that's in square feet, and that would mean that we wouldn't be able to change the state of a class commercial building in terms of its square feet. So the getter, all it does is return the square feet that's currently been stored there. The setter does a basic calculation to make sure that we have some positive value coming in. And the same is true for the other. In this case, parking places, in real life I had to go back and complicate this code because the parking spaces is actually a function of the square feet. I had a rather lengthy calculation here that determined how many parking places there had to be based on the square footage of this particular commercial piece of property. And that varies with the building codes in the city, and in fact it varies in the county based upon where the building is. So I didn't see any reason to put that code in here. It's pretty complicated and it makes no sense. Well, I mean, it makes sense, but it's not going to make sense just reading it now. Same thing for the public on this rent per square foot. She wanted it stated in rent per square foot, mainly because that's the way she judged the rate of return on investment was rents per square foot. That was important to her. And again, we use the decimal value because we're working with money. And it's important that you use this suffix when you use constants with the decimal value. Otherwise, by default, the compiler makes it an int, and that will draw a type mismatch error message. Now, once again, we get down to the general method, and you'll notice all of these subclasses only have one general method. I've tried to simplify this as much as possible. And again, it's the same remove snow method that we saw before. And we've overridden it because if there's a message or an event that comes in to the base class and there's a conflict because there's two remove snow methods, one in the base, one in the subclass, the override breaks the tie and causes the message to be routed to the subclass. So overriding is nothing more than, I always think of overriding as simply a tiebreaker. If an event takes place and we want to determine who wins the tie, this is what determines that tie. Okay, now let's look at the last one, class home. Again, we have to establish the inherited relationship between class home and class building because class home is a class building. So this is what ties us in. Again, we've used the private access specifier for all of our instance variables or our properties because we don't want to expose that data to the outside world. Once again, the constructor, we use a parameterized constructor or the default constructor. We can also create an object of this class by using the default constructor as well. And because all of the properties are private, the property methods also have to be written for each one of those properties. And they have to be public because they will form the interface by which we can talk to these different subclasses. And once again, at the bottom, there's no snow removal. Why not? Well, the reason is because we know that from this discussion with the client that it is up to the owner or the renter of the home to remove all snow. So there's no reason to have a remove snow message in the home subclass. If that's the case, then what happens when a snow removal message comes in? Well, because there is none in the subclass, we have to go to the base class and look at the snow removal message, which says no snow removal available. So when I run this, you'll notice for the home, no snow removal service is available. Yet, for each one of the other two subclasses where we did have that remove snow method, we get the proper message being displayed for the particular property that's involved.